Good afternoon, everyone. Thanks for joining us today. So what are we going to be covering today? Really briefly, our agenda looks like this. We'll be talking about the important role signal connectivity plays in the evolution of a smart city and how it helps promote efficiency in your everyday workflows. We're also going to unpack some of the challenges with current communication solutions and give you a view into ours. And we're going to wrap it up by sharing 3 customer stories and talk about how they use communications to instantly modernize both their traffic infrastructure and their teams using Miovision Traffic Link. If you were to ask 100 people what a smart city is, you'd likely get 100 different answers. This is because cities are at various stages of building their smart city strategies, and each has their own view of what a smart city means to them. For us here at Miovision, we believe smart cities start at the intersection. It's the natural hub of a city that serves as a center point for everyone: pedestrians, cyclists, cars, transit, and EMS. Because of all this activity, it's a place where you can deliver the greatest amount of impact to a variety of stakeholders, such as traffic teams, city planners, mayors, and most importantly, your citizens. It's also where you can begin to gather essential data to improve the mobility of your road users and ensure their safety. But where and how do you start transforming your intersections? This is the first and easiest step. The first and easiest step is signal connectivity and maintenance. As you see on the slide, we believe it's the foundational block in order to modernize your traffic operations and is the basis of any smart city. With it in place, you can layer on additional building blocks such as detection, permanent counts, and performance and safety measures, all of which provide an enormous amount of data and lead you to achieving your ultimate smart city goals. To put it simply, connectivity is about being notified of an issue in a timely and effective way so that you can quickly act to resolve the issue and ensure the fix works. If you think about this in everyday life, we receive notifications like this all the time. Whether it's a light on your dashboard indicating you need to take your car in for an oil change, or a notification from your banking app that you spent too much money eating out this month. These are all of these are alerts that cause us to take some sort of action to solve the issue. Now imagine having that power running through your traffic network, allowing you to see, diagnose, and fix issues immediately before they get out of hand.
What we determine to be, or what we call the conventional approach, is that citizen-centric, that citizen complaint-driven approach to traffic maintenance and operations. And this is some of the data that came back. Often this is what we hear as being the model today. Either traffic teams are waiting and hearing where citizens are having problems and relying on them to call in. We do hear traffic teams that predominantly spend their time driving around and manually finding issues. Obviously, reports in from fire and ambulance as they get reports that infrastructure is offline or not working correctly. This is where a lot of the data comes in. And once the data comes in, what we hear most is that comes and gets added to essentially a big long list of problems. And that problem list doesn't exactly shrink at any given point. It just kind of, as issues stem up or as they come onto the traffic team's radar, they just kind of join this big swath of other conventional problem that they're working on. Then from a prioritization point of view, it becomes really difficult to figure out which one of those problems is worth solving immediately and which ones can be solved later or less impactful. So traffic teams often find themselves fixing issues that are either yelled about the loudest or are driving the most amount of complaints. After that change is made, it's really hard to get data about if the change worked or not. So I went out and fixed the thing that citizens were complaining about, but is it the best change? Did the change work? Citizens stopped complaining, but did I really solve the issue? The lack of feedback presents a huge opportunity and huge problem for traffic teams. And last is, then I think most teams go back to their list of problems. So the kind of the problem list is always growing. It's fueled by citizen complaints, and you're kind of working and treading water to try to solve these problems as quickly as possible on top of all the other demands that are currently going into your traffic team. So this is the conventional approach in discussions with customers. I hear often that it's frustrating, it's inefficient, and that there has to be a better way. When we look at this approach from the Miovision perspective, we think there's ways that technology can help solve these issues and allow traffic teams to be proactive in nature. So imagine a world where your infrastructure itself was automatically able to detect problems at that intersection. So power loss, congestion, safety issues. Imagine if the infrastructure itself was able to send you a message and let you know that there was something wrong. And then what if it would automatically generated the alerts and assigned issues to the correct people to allow them to actually go and triage those issues with the right tools at the right time. And then not only that, but then quantify and solve the most important issues. So again, if I have 3 intersections or 3 parts of infrastructure that are currently failing, which one's the most important one to fix? In what order should we do it? And then how do we actually make sure and measure that the change was made? So this new paradigm actually allows traffic teams to cut out citizen complaints by eliminating them before the citizens have a chance to complain. So rather than being reactive and waiting for citizens to be having the issue, you become the hero that's automatically solving these problems when they arise. Our customers that have kind of undergone this journey and that Shannon's going to be sharing later in the webinar have found this to be just not only a better model for citizens, but a better model for them internally, where not only are they not getting the complaints and their bosses and the city managers are not hearing those complaints anymore either, but there's just a better use of city resources that allows them to tackle either more of these kinds of problems or move on to some of the other things that demand our traffic team's time. And I know in this day and age, there's no shortage of things for traffic teams to be focused on. So eking out this kind of efficiency by moving to a new model is really, really great for everyone involved. We make this possible with a piece of technology that we call the Smartlink. So the Smartlink's only purpose and what it was really built for was to just make a really, really easy job of both providing connectivity to and an integration into your traffic signal network. So the Smartlink itself, it's built to really quickly, for your existing controllers and cabinet devices, plug in, no upgrades required. In a few minutes, you have all the use cases that we've talked about above through a simple plug and play integration. And that means not only do you get connectivity, but you get the cabinet monitoring, you get health monitoring from your cabinet. You can tell issues like power loss, flashing lights, broken detector loops, intersections on UPS, all that rich maintenance data that would allow you to triage and know where your issues exist. You also get lots of other benefits, including reading SPAT data off the controller. It functions as a travel time device. So if you're thinking about deploying niche products that just collect travel time, Smartlink provides that out of the box just through connectivity alone. It also includes a GPS time sync. So if you're worried about drift or other issues across your network when you're trying to coordinate, Smartlink includes that feature as well. It also really, really simply plugs into your other parts of third-party hardware. So again, no matter the type of controller that you have, it plugs into your conflict monitor. I can tell you again if your intersection's on battery or not, but also can tie into your central management system. So if you have a mix of controllers within your network, it allows you to bring the intersections that currently aren't upgraded or have older controllers into your CMS platform by providing connectivity to them. The last thing to say here is that the unit down at the bottom of the box, at the bottom of the Smartlink, that is the LTE antenna that we use to supply connectivity. So our connectivity is over cellular, it's over LTE, but we can also plug into existing connectivity if you have that at your intersection. So if you've invested in something like fiber to parts of your network, that's great. We can actually just plug into that fiber and provide all this monitoring off the back of that. But if you've got a mix of technologies within your network, you've got some of your network has fiber, some of your network has old radios, some of your network has spotty connections, we can come in and we can fill those gaps for you. So whether you're starting from a somewhat connected point of view and you're looking to fill in gaps, or you have no connectivity at all or very low connectivity and you're looking for just the means to get your intersections quickly online without paying or waiting for, say, fiber to be buried, the Smartlink makes it really, really easy and simple to just plug and play and bring your infrastructure up to speed. Some of the alerting, and I'm going to do a quick demo to actually show you what this looks like in the software, but the screen down below is actually one of our customers. It's a large deployment, 450 intersections. And one of the primary use cases is just knowing when and where issues occur at the scale of their entire network. And these issues include everything from power loss to signals in flash, to the detectors are not working, a complete loss of connection, or if we have prelamp preempts actually exceeding the limits. And what this unlocks for a city at this scale is it's very hard for them to maintain not only the size of this network, but the distance that you would have to travel to get out to some of the rural areas is really far. So if you're doing things without the data and you have to drive 30 minutes in a truck just to go see if the issue is real or not, and then drive all the way back to the office to get the right tools to fix it, and then drive back out, it's a huge amount of wasted time and effort when there may not actually be an issue there to begin with, or the issue would have resolved itself. So being able to have all this remotely for all these smart alerts is really valuable. And we make that available via email within our interfaces, and down below, you can actually see that we can send out these alerts via text message as well. So that keeps everyone in the loop, and you can actually program into the software who you want to get notified when these kind of issues occur. And again, most importantly, when we talk about coverage of a network, if you do have a central management system and you've invested in that technology and you're looking for ways to bring more of your intersections that are unconnected into your CMS, we do integrate with all the existing CMSs today and make it so it's really easy for you to build a holistic view within your CMS of all your intersections. So we're happy to be both the front end that's deploying that information, but also I think there's lots of value that we can provide in bringing more intersections into your existing investments as well by supplying a really easy turnkey communication solution. And the last point I'll touch on before I go to the demo here is security is a huge factor in all of this. So even if you were to get connectivity to your infrastructure, securing it is an entirely other task. So if, let's say you were to say invest in off-the-shelf modems or a more specific device that didn't have security in mind, it becomes really hard to both secure that physical asset in the field. So how do you prevent something from going wrong with the infrastructure itself? To then securing the connectivity and the communications chain between that device and either your servers or the cloud. So when you're thinking about doing your own homebrew kind of solution, it's really hard to get this right. And we spend a lot of time both on our hardware and software of, in securing all this data. So if you kind of work from left to right in this chart, you've got the traffic controller with the pieces of hardware inside of it. What we do is we actually secure all that data within a VPN tunnel. That VPN tunnel goes right to the cloud where all the data is hosted, and that allows you to have fast, reliable access to all that data and to your signals without the risk of any sort of security breach. So all this is designed with security in mind from the start, and we leverage a lot of security partners to ensure that our connections and our equipment is as secure as possible. So in this age that we live in, where security is both a massive topic for cities at large, it's important for us in traffic to also be thinking about how what we put into the infrastructure is secure by design. So what I'm going to do is I'm actually going to pop out here on my screen and show you a little bit of TrafficLink live. So this is a local deployment. This is actually just around our office. And this is the map view. So this is kind of the view of your network. The example I had in the PowerPoint was a much larger scale. This one doesn't have as many intersections deployed, but has a few really interesting things here that I want to show you on the map view. So all these intersections are connected. You can see the green ones are actually ones without camera. So we do have a camera, and I'll get into what that looks like as well. But anything without a camera is just supplying connectivity and reading data back from that intersection. Any of these little green dots with a camera is actually one that we can tune into and see what's happening live at that intersection. Now what you'll see is there's a few green dots that everything looks fine, but then you see some alerts happening on the map. And this is issues that are going on live right now within this traffic network. A few that I can touch on is you have a few that have connectivity alerts. So if I click into any one of these, I can see actually the NTC IP from this controller is not currently working, but I can also see the controller type and the connection information for that intersection. Along this corridor, we see having a lot of issues, specifically around detection thresholds being exceeded. So in this case, they have in-ground loops, but those in-ground loops appear to be broken, and they don't appear to be really firing as we would intend them to. And we've set thresholds within the software that allow us to identify and speak to those issues and get the alert that our detection is not working as intended. The other really interesting one that I find on this map is outside the city, there's a little town called Baden. And Baden has one intersection, and it's managed by the region of Waterloo. I think it has one intersection. I'm sorry if there's anyone out there from Baden and I'm saying that you've only got one intersection, but I believe they only have one. And in this case, you can actually tell remotely that this is on UPS battery and currently experiencing power loss. Now, if you're the city and you're managing this intersection, the last thing you want to do is have to get into your truck and drive all the way out there to figure out what's going on, drive back, get your tools, then drive all the way back out to Baden. So in these rural areas that have infrastructure that need managed, connectivity is a huge benefit when able to remotely diagnose and manage these intersections. So a really cool use case that involves adding connectivity to units outside the city to be able to actually monitor their health. But I'll pick a single intersection up here at Glasgow and Westmount. This is just off the street from our office. And if I click into that, I kind of get the overview of the intersection. I can tell again what equipment's there. And I can actually go to the telemetry and see all the data that's coming back off the controller in real time. So in this case, I have both the signal view, which tells me how the signal's performing, pedestrians, I can tell what preamps are happening, and also what detectors are live. And not only can I tell that in real time, but I actually have a historical view, where if I want to go back in time and actually zoom out and say, I want to know what was happening yesterday, I can actually warp back in time and know exactly what the controller and the infrastructure was doing. And this becomes really important if you try to do any auditing or trying to go back and discover what are the issues that citizens or people were talking about on any given day. All this data is collected for you and hosted for you and allows you to easily get here and actually discover what was happening with your infrastructure. We also have something like the timing diagram where we can see exactly how the controller is timed and what we can expect for that controller to be doing and behaving with all the detector outputs, the preempt outputs, and the phasing information all live coming from the dashboard. But also, again, we can tap in historically and know exactly how that intersection was behaving. So again, once the intersection is connected, not only can we remotely see how it's behaving and what alerts are coming from it, we have access to all this data coming back off the controller, both in real time and historically as well. One of the other benefits is if you add a camera to the intersection, you can actually go live to that intersection utilizing its connectivity. So in this case, this intersection is connected via LTE. So what we're going to do is we're going to tap into that LTE connection and we're going to go live. So again, this is not even over fiber, this is over LTE. And if I make this a little bit larger, hopefully the stream can keep up with the video, we can see a few things happening here in real time. Not only can we tap into this camera to see what is happening at the intersection, but also we can recall the video to go back in time as well. So if you're looking to see what physically happened at an intersection or what's happening live at an intersection, that connectivity in the camera can actually provide you the method to diagnose either historically or in real time. Now in this intersection, we actually have more than just connectivity here. We actually have a unit that we call SmartSense that is providing in real time video detection, which is some of the boxes that you've seen drawn here, as well as continuous data collection via the turning movement count diagram up in the upper left-hand corner. So this intersection, although connected, although it aligns with what Shannon was saying, that once you have that connectivity, you can layer a whole bunch of more advanced use cases on top of that connectivity to provide even more value from the intersection. But certainly, once you provide connectivity, all these use cases become to start being unlocked, so you can start to drive more value from your connected infrastructure. And again, if you actually want to go back to and look at the video recordings, you can do that historically. Based off all that data we're also collecting, it becomes really easy to generate some ATSPMs, automated signal performance measures, that again, take that data coming off the controller, off the detectors, and that SPAT data that we're all connecting, that really rich data, and start to aggregate it in a way that traffic teams can use it to make performance-based improvements to their network. So rather than relying on signal timing, you can take more of an active approach where you're reading that data in real time from your connected infrastructure, then putting in real world changes in a more agile way to solve traffic problems in real time without waiting for the next retiming project to come down. So that gives you a quick overview. Again, if you're interested in the software and more of the capabilities, I would love to go into deeper on any single one of these demos, but it gives you a quick kind of idea of the benefit you get from connecting your signals and what kind of data you can start drawing back from the network once you do so. So just to recap, I think that the fastest and smartest way to get your traffic cabinets connected is you're going to be looking for a few key features from any vendor that you're working with. One is you're going to look for a vendor that's backward compatible. So make sure that all of your existing controllers, without adding or replacing them, can be upgraded to supply connectivity. Now, this is where Smartlink is a really great device because it's built with that compatibility in mind. And we've integrated with controllers all over North America of every type and of every age to provide this sort of remote connectivity to that controller. Any solution must have security in mind and be built around security. And that means, actually having those complex VPN tunnels as part of the product and not needing to work with other teams or rely on other teams to secure your infrastructure. And the last one is future-proof. So any sort of investment that you're making into your city should not only be built to take on further use cases into the future, but also should be built on open technology. So technology that allows open integration, API-based integrations, technology that doesn't lock you into a specific vendor, but instead extends your intersections into being both agnostic of technology, but being platforms that you can build use cases on top of and that you can grow, and that you're not going out and buying a niche piece of technology for every single use case. There's not enough room in the cabinets anymore. So we need to be consolidating to common platforms and platforms that are open in nature so multiple people can use them to achieve smart city goals. So we do this, again, we talked a little bit about Smartlink today, but Smartlink is part of what we call the Traffic Link family. And Traffic Link is essentially what we say makes smart intersections super easy to deploy. In this case, Smartlink is going to be what provides that communications, our topic today. It has the LTE card, but it can also, again, integrate with your existing comms if you have fiber or another set of connectivity. But in addition to that, some of the capabilities that we saw in the demo leverage Smart Sense, which is the real-time compute, and that is the real-time processing that happens at the intersection. And of course, we saw the view from the 360 Smart View camera that, again, has 4K resolution, allows you to see remotely what's happening at the intersection, but also is a video sensor that produces data based off of our computational device at the roadside. So again, this topic today is more focused around Smartlink, communications and integrations, but again, at any point, really happy to talk about the entire Traffic Link family and how the Smartlink fits into the broader applications that you could deploy at an intersection. Some of those use cases for us include, so you see signal communications as being one of the top boxes, signal maintenance, we talked a lot about that, but certainly traffic operations teams using data to manage the performance of your network in terms of ATSPMs. We do provide detection, multimodal detection, and then continuous data counts as well. And again, they're all off of this same system. So the stack and the way to your smart city, you want to invest in a technology that, although starts with signal communications, is capable of doing a lot more. And certainly by starting with Traffic Link and with Miovision, you're able to use your existing investment to then extend and do more across different teams and across different use cases of the technology. So by buying a platform that can do more, you're not going out and again buying other technologies that solve just one of these problems. That's certainly the value that Traffic Link brings to the table. So at this point, I'm going to hand things back to Shannon. I'll be back at the end for questions. If you've got some, feel free to leave them. But I'm going to go back to Shannon here, and she's going to run us through some stories about how our customers are leveraging communications to really improve their traffic networks.
Great, thank you, Matt. And like Matt shared, we thought we'd dive right into 3 different customer examples of folks who've deployed Smartlink and the positive impacts it's had on their teams and their traffic networks. So the first one that we wanted to take a look at is the city of Detroit. When we first started working with them, they had 3 challenges that they wanted to address: signal maintenance, traffic congestion, and safety. Similar to many of the major cities in the US, Detroit was faced with an aging infrastructure and had very little in-ground connectivity, which left them unable to communicate with about 80% of their signals. On top of this, Detroit's traffic team was very lean and had to outsource a lot of this work to a third-party contractor, which ended up being a huge line item on their operational budgets. So they needed a tool that would automatically detect problems, send alerts and assign issues to the right people, triage the most urgent issues, and measure the impact of that fix. And that's where we came in. So now we have TrafficLink installed at several of the intersections across the city, and it's completely transformed the way they identify and solve issues in their network, and it's significantly reduced their contracting costs. With a live view of their connected intersections, the team can now prioritize their most critical problems. Technicians receive real-time text alerts that send the right staff to the right locations at the right times, and issues are resolved quicker, ensuring that there are safe road conditions, that unsafe road conditions don't persist for their citizens. For Detroit, connecting signals was just a start. Today they're using data insights collected by TrafficLink to improve congestion and safety across the entire city. As Detroit discovered, a smarter traffic network was started by ensuring signals are connected. So Matt already touched on this story a little bit, but the next story we wanted to share with you is right in our own backyard, our home base, the region of Waterloo. Our region is home to about 500,000 people, and it's spread over about 500 square miles, with a small traffic team that's responsible for about 500 traffic signals. Like Detroit, the team relied on citizen complaints to prioritize their traffic issues, or drove around to find problems, which consumed way too much of their time. But unlike Detroit, they didn't have a budget for a third-party contractor to help them with the issues. They needed a way to manage and respond to problems instantly and efficiently. By installing Smartlink, the team started receiving immediate alerts of issues in the field, which allowed them to react and put a fix in place immediately. What's more, the region has our SmartView 360 camera installed, like Matt showed you. So now, once they are alerted to the problem, they can see exactly what's happening at the intersection in real time. To give you an example of this, an accident recently occurred at one of our busiest intersections. It was the type of incident that not only severely impacted the traffic at the intersection, but the alternative corridors. In this case, the team was alerted to a spike in travel time along the corridor, which prompted them to take a look at the video feed of that particular intersection. And by doing so, they could see exactly what was happening to cause this spike and respond accordingly. They had all the information that they needed without even having to leave the traffic control center. So for the region, TrafficLink has become a key tool that allows a small traffic team to effectively manage a large traffic network across a large area. So our third story we wanted to share with you is Orange County, Florida. And when we started working with them, they actually had about 90% of their traffic signals already connected to a fiber network. And they were able to, and because of this, they were able to monitor and manage them from their TMC in Orlando. Having a view into their network was incredibly important, considering the county has about 1.3 million residents and another 72 million visitors a year. So they need to move those folks safely throughout the region. The challenge that they faced was managing and monitoring their unconnected signals in the remote areas of the county, where many of the hospitality workers now live in new developments that have caused an influx in traffic and congestion. Some of these intersections were more than 30 minutes away from the office, similar to that story here in the region of Waterloo, where we have Baden that has a single intersection 30 minutes out of town. So similar to the traditional approach we talked about earlier, when there was a problem, it was often reported by a citizen, and then a technician had to hop in a truck, drive out to the problem, and then diagnose it and fix it. Once again, a big waste of time and stress on an understaffed traffic team. So why not lay more fiber to connect the remaining signals? As Matt shared earlier, it's expensive and often requires tearing up the roads, which of course would cause a disruption to traffic. So officials were looking for another way to connect these signals. By adding Smartlink to the intersections in the outlying areas, the traffic engineers are now able to monitor and adjust the previously unconnected controllers directly from the TMC and reduce the time wasted traveling out to these areas to get a view of what's happening. We were also able to solve another unique challenge for the county. They had a network of about 10 traffic signals in one of these outlining areas. They were connected to each other by fiber, but none of these signals were actually connected back to the TMC. something you can consider like a fiber island. By installing Smartlink at just one of these 10 intersections, the county got the benefit of having all 10 intersections connected back to the TMC. That itself saved millions of dollars that it would have cost to connect the island to the rest of the network. As you can see by these three stories, regardless of your network size or whether you have some or 90% of your signals connected, TrafficLink, and more specifically Smartlink, can help you stay connected, improve your workflow, and reduce your overall operating costs. So I think that's it for our content today. We hope you found that valuable, but we thought we'd spend the last few minutes answering some of the questions that have come in. Of course, we'll answer as many as we can get to, but our contact information is up on the screen if you guys wanted to reach out to us directly afterwards. And then do stick around for the last few minutes after the webinar as we have some additional information to share with you.
So maybe we'll just pause the mic here quick while we pull up the questions, and we'll be back here in just a second. So feel free to enter those questions right now, and we'll be back in a moment. Okay, so maybe I'll just start going through them here. Sorry, we had a little bit of echo there. So one of the questions was one of the cities we were showing in the diagrams Detroit? That is correct. So if I go back a couple slides, you can see that Detroit is one of our customers. Again, they have a huge deployment with us, and they were one of the initial customers that found a ton of value in just having that infrastructure online. So when Detroit first started as a customer, their predominant problem was that they would have a lot of rolling brownouts in the city, so a fairly unstable power grid. And as that power grid would fluctuate, it would then leave the signals in a state of disarray, so either power loss events or flashing lights. And the city of Detroit was relying on citizens to call in after those brownouts and tell them where the issues occurred. So one of the huge first steps that the city of Detroit took to mitigate this ultimately safety risk was connecting those signals so they weren't relying on citizens to call in after those rolling brownouts. So yes, that is the city of Detroit, and that is a little screenshot of their deployment there at the bottom corner. I have another question. Can we get a copy of the PowerPoint? Yeah, we sent out a copy of all these presentations after the webinar. So if you look to your inbox, you'll receive a copy of this recording that you can either watch again yourself or send to a friend or someone else you may think would find it valuable. So a question here about smart corridors. Can the platform create smart corridors? So absolutely. The way that we look at it is either at a particular intersection, a corridor, or a network point of view. And we have solutions and data and analytics that approach all three. So if you're looking to both optimize a single intersection, you can do that. But certainly when it comes to doing things like measuring congestion and using travel times, we do a lot of work from that point of view in a corridor way. So again, ensuring that corridors are properly timed from a more proactive point of view than say a signal retiming. But also, if you're looking at the broader network outside of a corridor, making sure that your corridor is aligned and you're optimizing for not just your corridors and your intersections, but the entire city as well. So obviously, the more you connect, the more you're able to aggregate that data and optimize across all those locations. So a question here about what ATSPMs are generated. Can they do transit, bike, and intersection movements? So ATSPMs today are focused mostly on our vehicles, but we are looking at technologies including adding pedestrian compliance and cyclist compliance to our platform as well. So how can we bring pedestrians and other modes into our ATSPMs that we generate? The other thing that is also a focus for us, and something that our platform does right now, is it produces that multimodal data in terms of continuous counts via TMCs and volumes. And that includes both vehicle classes and the other modes of transportation as well. So from the same platform, you can both generate the ATSPMs, but you can also generate multimodal data and counts, all from the existing and from the same system. So a question here about conflict monitors. Important to state agencies, how's your equipment interact with conflict monitors? So our equipment reads data from the conflict monitor, and we can tell you what is happening off of that conflict monitor remotely. So where we interact is we are reading data from it, and we pull data from it, and we can alert you remotely when and where and why there is something going wrong with the conflict monitor. Some questions in here about price and fees. I'll defer kind of the broader pricing discussion. It really depends on who you're working with at a state level. So if you have any questions about pricing, feel free to just send us an email, or maybe we can follow up with you offline and get you connected with one of our local distribution partners who can have a conversation about pricing. So a question here about how does it recognize faulty detectors? So the way that it works is we set basically alarm thresholds for how much a detector should be on. And based off of those thresholds being either exceeded or underperforming, we can send an alert based off of that. So let's say you have a loop that should be going off and you've set a threshold where it doesn't, we would then send you an alert to say, hey, your detector is not working here. Or let's say your loop is performing poorly and it's stuck on, we would say, hey, this detector has exceeded a threshold and this detector is broken because it has been on, say, all day and placing a call all day. So we recognize the faulty detectors by doing analytics around how often they are stuck on versus not on relative to how much they should be. And we do allow you to configure what those thresholds are and when you receive those alerts. So a question here about incident detection and its automation. So today we do not provide incident detection or an automated version of that. So just to be clear, we would, again, report on information and problems and alerts coming back off of the traffic controller, or again, other equipment within the intersection that is doing kind of power loss events or any other infrastructure problems. We do not do any sort of automatic incident detection today. So a question here about kind of what is the typical communication? Is it using NTCIP? Yeah, we can integrate over NTCIP. We also have interfaces that we build ourselves that help us integrate into older controllers. So in some cases, yes, we can use NTCIP, but it really depends on the age of the controller and the communication protocol. But certainly, if your controllers have NTCIP, we can use that. There's a question here about how far back the historical video goes, and is it stored in a circular buffer? So that's a great question, and your question, you astutely answered it in there. So we do hold 7 days worth of video, which is then rewritten over the course of 7 days. So again, that is to make sure that if you have an incident, you can go back and pull that video, but we're not storing that video indefinitely. So again, we have a software feature that we call video recall, that again, if you want to go in and pull that video off the device, you have 7 days to do so, and you can download a copy of that to your system. So question here from Joel, is it fair to summarize the solution as a health monitoring and maintenance solution with a layer added for data collection and stats? That's certainly a component of it. I would say that the solution that we're talking about here today is for sure around health monitoring and maintenance and those use cases. One of the benefits of TrafficLink, the product, is that it does far more than just those things. So again, if you're looking for a way to easily get health monitoring and maintenance kind of capabilities into your traffic network, TrafficLink and Smartlink are a really easy way to do that. But then we allow you to layer hardware and software on top of that to achieve more use cases, including those turning movement counts, classifications of multimodal users, detection and actuation, all off of the same platform. So certainly the most, in this case, we're start with connectivity and start with these kind of features, but we do allow you to do far more with the platform than just those things. So it is both a health and monitoring solution, but also far more. So I'm just gonna go through the questions. We have some repeat ones, so I'm just kind of going down the list. So again, there's a few questions about the LTE connection and the costs. So yes, there is an LTE connection that we use to connect those signals, and that LTE connection does have an ongoing cost. It's just it's a SIM card in there, and just like you would pay for your cell phone or for any other device that's connected, there is a ongoing fee from the carrier for that. So again, any specific pricing, feel free to drop me a message and I'd be happy to connect you with someone on terms of pricing. But just to be clear, yes, there is a ongoing cost in terms of connectivity, because there is the active internet connection in the SIM within the appliance itself. So a question here around integrations. So a question around, can you control the data and also adaptive? So we do provide lots of basis for integrations and other solutions as well. So if you do have questions about how you integrate Smartlink into your other systems and what capabilities it has for those integrations and what other stuff it can unlock, again, feel free to send us a message and we'd be happy to share that information as well.